Good day everyone, I am Rovelyn Agudelo together with my partner Marilett and today we will talk about the water and life on Mars. So, we all know that of all the planets and moons in the solar system, Mars seems to be the most promising place to look for life, for both fossil microbes and some forms of life deeper underground that will survive today. But first, let us all know our learning objectives. The first one is to describe the general composition of the atmosphere on Mars. Explain what we know about the polar ice caps on Mars and how we know it. Describe the evidence for the presence of water in the past history of Mars. And lastly, summarize the evidence for and against the possibility of life on Mars. Now, let's talk about the atmosphere and clouds on Mars. The atmosphere of Mars today has an average surface pressure of only 0.007 bar, less than 1% of Earth. Martian area is composed primarily of carbon dioxide, which is 95%, with about 3% of nitrogen and 2% of argon. Firstly, let's talk about pressure. On the Earth, we're accustomed to feeling the weight of the atmosphere pressing down on us, which we measure as atmospheric pressure. However, on Mars, this pressure is drastically lower. To put it in perspective, if you could stand on the surface of Mars without a spacesuit, you would feel like you're at the top of a very tall mountain on Earth. Now, let's look at the composition of Martian air. Mars' atmosphere, which is predominantly nitrogen and oxygen mass in area, is primarily composed of carbon dioxide, making up 95% of its atmosphere. That contrasts of the Earth's atmosphere where nitrogen dominates. It also said that the winds on Mars can reach high speeds. They exert much less force than wind of the same velocity would on Earth because the atmosphere is so thin. As we discussed earlier, the atmosphere on Mars is incredibly thin, with a surface pressure of only 0.007 bar, much less than 1% of Earth's atmospheric pressure. This means that there are far fewer air molecules present in the Martian atmosphere compared to Earth's. Although the atmosphere contains small amount of water vapor and occasional clouds of water ice, liquid water is not stable under present condition on Mars. Part of the problem is the low temperature on the planet. One of the primary reasons liquid water is not stable under present condition on Mars is the planet's low temperature. Mars is much colder than Earth, with average surface temperature hovering around -60 degrees Celsius or -80 degrees Fahrenheit and dropping even lower at the poles during the winter months. These frigid temperatures are well below the freezing point of the water, which is 0 degrees Celsius or 32 degrees Fahrenheit under the Earth-like atmospheric pressure. Now, let's talk about the cloud on Mars. Several types of cloud can form in the Martian atmosphere. First, there are dust clouds. Second are the water ice clouds similar to those on Earth. These often form around mountains, just as happens on our planet. Finally, the CO2 of the atmosphere can itself condense at high altitudes to form hazes of dry ice crystals. The CO2 clouds have no counterpart on Earth since on our planet, temperatures never drop low enough down to -125 degrees Celsius for this gas to condense. Next is the polar caps. Through a telescope, the most prominent surface features on Mars are the polar caps, which change with the seasons, similar to the seasonal snow cover on Earth. These polar caps are primarily composed of frozen water and carbon dioxide, also known as dry ice. As we can see on the picture taken by the Mars Reconnaissance Orbiter, in picture A, it shows that mostly water ice residual caps sitting atop light, tan-colored layered sediments. While in picture B, here we see a small section of the layered terrain near the Martian North Pole. There is a mount about 40 meters high that is sticking out of a trough in the center of the picture. Now let's talk about the type of polar caps on Mars. First is Southern Permanent Cap. The southern permanent cap that's out there in permanent car parks has a diameter of 350 kilometers and is composed of frozen CO2 deposited together with a great deal of water ice. Throughout the southern summer, it remains at the freezing point of CO2, which is 150 Kelvin, and these cold reservoirs thick enough to survive the summer heat intake. Next is the northern permanent cap. The northern permanent cap is different. It is much larger, never shrinking to a diameter less than 1,000 kilometers, and is composed of water ice. Summer temperatures in the north are too high for the frozen CO2 to be retained. Now, let's discuss the channels and gullies on Mars. Although no bodies of liquid water exist on Mars today, evidence has accumulated that rivers flowed on the red planet long ago. Two kinds of geological features appear to be remnants of ancient watercourses, while a third class, or what we call smaller gullies, suggests intermittent outbreak of liquid water even today. In the highlight equatorial plains, there are multitudes of small, sinuous, or twisting channels, typically a few meters deep, some tens of meters wide, and perhaps 10 or 20 kilometers long. They are called runoff channel because they look like what geologists would expect from the surface of runoff of ancient rainstorms. This runoff channel seems to be telling us that the planet had a very different climate long ago. The second set of water-related features we see are outflow channels are much larger than the runoff channels. The largest of these, which drain into the Christ Basin where Pathfinder landed, are about 10 kilometers or more wide and hundreds of kilometers long. Many features of these outflow channels have convinced geologists that they were carved by huge volumes of running water, far too great to be produced by ordinary rainfall. Some scientists believe that these outflow channels were likely formed by catastrophic flooding events triggered by the release of water stored beneath the Martian surface. This water may have been trapped underground in aquifers or locked away as ice, perhaps even due to volcanic activity or impacts that melted subsurface ice. The third type of water feature are also known as the smaller gullies. These gullies are very young. Not only are there no superimposed impact craters, but in some instances, the gully seems to cut across recent wind-deposited dunes. The gullies also have the remarkable property of changing regularly within the Martian seasons. Many of the dark streaks elongate within a period of a few days, indicating that something is flowing downhill, either a water or dark sediment.
Hello everyone, I am Marilett and let's proceed to my topic. Ancient lakes and glaciers. The rovers mentioned, which are the spirits of opportunity, curiosity, and perseverance, are used or ginamit ito para makakuha or makakalap ng evidence about signs of waters in Mars. Based on my research, yung rover is a robotic vehicle designed to explore the surface of a celestial body like planet or moon. And actually, madalas may mga instrument or cameras ito that gathered data and images which transmitted back to Earth for analysis. So ayun na nga, although they couldn't access certain locations like gullies on steep slopes, they investigated areas suspected to be dried out lake beds. And also, sinasabi din dito na past period, mas denser yung atmosphere and warmer, kaya there is a potential that it supports liquid water on the surface. The first one is the Spirit rover. So, ang target nito ay ma-explore yung Gusev crater. This crater is about 166 kilometers in diameter and formed 3 to 4 billion years ago. So, ayun na nga, sabi nga dito, nung nagland yung spacecraft, sa halip or imbes na sedimentary rocks yung makikita nila or dahil yun nga yung inaasahan nilang makita, iba yung kanilang na-discover. So, nakita na yung dating lawa ay nakakover na ng thin lava flows. Kaya nahirapang maka-access yung Spirit rover dahil nga nakaharang yung thin lava. So, the second one is the Opportunity rover. So, sinasabi dito that Opportunity had better luck. Bakit kaya? Let's see. It says that Opportunity detected layer of sedimentary rock upon peering at the wall of the small crater. So, yung mga rock pala na yan contain chemical evidence of evaporation, meaning there is a shallow salty lake in that location. And also, in these sedimentary rocks, there is a small spring na mayroong mineral which is hematite. So, yung hematite kasi is isa siyang mineral na karaniwang nabubuo sa mga environment na mayroong tubig. So, apparently, sinasabi dito na this had once been under water. The next one is the Curiosity rover. It successfully landed inside Gale crater, which had been identified as a potential site of past water erosion. It is a large impact basin with a massive layered mountain in the middle. During its exploration, na-discover nito na mayroong numerous sedimentary rocks dito, including mudstones na pinaniniwalaang from an ancient lake bed. And also, it found evidence of rocks na na-formed by the action of shallow at the time the sediment was formed. So, these findings provide strong support for the idea that Gale crater once contained liquid water. Even now or in our present days, may mga evidence pa rin na there is a substantial ice deposit beneath the surface of the Mars. The last one is the Perseverance. It tells that this rover explored crater G0. This crater is a dusty former lakebed and river and may evidence din na may mga large rocks na naiwan ng ancient floods. Itong mga glacier na ito is nabuo siya during warm periods, kung saan mas mataas yung pressure ng atmosphere and maybe the snow and ice could precipitate. Next one is the climate change on Mars. We all know naman na like Earth and Venus, Mars probably formed with a higher surface temperature, and it is because of the greenhouse effect. However, over time, the planet lost its atmosphere due to various factors such as the sun's solar wind stripping away lighter molecules, Mars' weaker gravity not being able to hold onto its atmosphere, as the atmosphere din yung greenhouse effect which helps trap heat and maintain temperature diminish or bababa ito. So kapag bumaba ito, Mars will cool further and it will cause water to freeze out of the atmosphere and also the surface. So meaning kapag na-reduce yung ability ng atmosphere to retain heat, mas magiging cooler yung environment. So sinasabi din dito na the planet experienced a runaway refrigerator effect, just the opposite of the runaway greenhouse effect that occurred on Venus. Meaning, instead of getting hotter like planet Venus, the planet Mars experienced cooling effect. So magkasalungat sila ng planet Venus. And also, Mars is likely to experience a long-term climate cycles na nagiging cause dahil sa pagbabago ng orbit and tilt of the planet. These variations affect distribution of sunlight reaching different parts of the planet, leading to changes in temperature and atmospheric conditions over time. When the polar caps melt due to these fluctuations, they release water vapor into the atmosphere, influencing the climate. The next one is the search for life on Mars. So, as you can see, these Viking experiments, so these landers' primary objectives includes testing for microorganisms in Martian soil using miniature biological laboratories. These experiments involve isolating soil samples and incubating them with various gases, radioactive isotopes, and nutrients to detect signs of life, such as respiration, nutrient absorption, and gas exchange. Additionally, soil was pulverized and analyzed to identify organic material, particularly carbon-bearing compounds. Yung carbon-bearing compounds are molecule that contain carbon atoms and bonded to other elements katulad ng hydrogen, oxygen, nitrogen, at iba pang elements. Ginamit ito ng Viking lander experiments para ma-detect kung mayroon nga bang presence of life on Mars dahil nga itong compounds na ito is essential for life as we know it on our planet, which is Earth. But, to the disappointment of many scientists, no life was detected on Mars. And yung activity na na-observe nila nung tinest nila yung soil, which is yung nutrient absorption and gas exchange, ay dahil lamang sa chemical reactions na na-initiate ng water na inad doon sa soil, rather than signs of life. So, these experiments indicated na yung Martian soil is mas chemically active yung Martian soil kaysa doon sa terrestrial soil. At dahil na rin siguro mas na-expose ito sa ultraviolet radiation dahil nga ang Mars ay walang ozone layer. Dahil alam naman natin na yung ozone is our protection against some harmful UV rays. So kaya naman napakahirap kung walang ozone layer ang isang planet like Mars. So yung organic experiments naman na kinandak ng Viking experiment din showed no trace of organic material in Martian surface. At dahil na rin ito sa epekto ng ultraviolet which likely destroys organic compounds exposed to the Martian surface. Despite Mars having the most Earth-like environment, current evidence suggests that there is no life present on its surface.